Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin HARIZAN. Today my group will present about material use in corrosive environment. Before we proceed with our presentation, I would like to introduce my team members. So in this group we have 5 people. First we have Khairul Anuar. Second we have Muhammad Ashraf, which is myself. Third we have WANDO SIMANULLANG. Fourth, we have DIYAANAH, and the last one we have FARAH HUSNA. So in this presentation, we have 6 content here. First, we have introduction. Second, type of material. Third, physical properties. Fourth, mechanical properties and microstructure. Fifth, fabrication method and application. And the last one is conclusion. Okay, so first content, we go to the introduction. So the corrosive environment is categorized by air, soil, water, acidic, alkaline, and combination of these. So second, other factors, we have pH, temperature, and the presence of biological organism can influence how the material is spawned, or else the lifetime of the materials based on the corrosive environment listed. So the corrosion resistant material is really important in production because the characteristic of the material can make the material long last in any corrosive environment. So for example, we have stainless steel is widely used in construction, machine building, and the production of storage container because stainless steel have high melting point and strong pressure resistance. So another example, we have aluminum, which has high strength to weight ratio and excellent thermal and electrical conductivity, and also aluminum are non-toxic and are completely recyclable. Okay.
Assalamuaikum. My name is FARAH HUSNA binti AZHAR, and I will present to you the details on the type of the chosen material in corrosive environment. First of all, the selection of suitable material to use at corrosive environment must be carefully considered to ensure its quality and for a long-term use. Why it is important to choose the suitable material? This is because of the corrosion of metal might eventually result in leaks and spills, most crucially leading to the collapse of the structure. Therefore, the material that we have decided to use that are suited for corrosive environment are stainless steel and aluminium, given to its capability in preventing the rust based on its corresponding mechanical and physical properties. For the stainless steel is a green material being utilized in a wide range of applications such as kitchenware, surgical and medical equipment, and many more. This metal was chosen primarily for its excellent corrosion resistance, as it is basically made up from multiple kinds of elements, which primarily consists of ferrum, carbon, chromium, and nickel. The presence of high chromium in stainless steel with estimation of more than 10.5% composition is what makes it resistant to rust and corrosion. Chromium has the ability to prevent rust formation, which enhances corrosion resistance, protect underlying metal, and harden the steel, as it forms an oxide layer on the steel surface called chromium oxide immediately after being exposed to oxygen. Besides, when nickel is added to stainless steel, it enhances an extremely sturdy and ductile metal with great impact resistance and the ability to tolerate high temperature. Stainless steel is commonly used in the food and beverage, construction, and automobile industries. For aluminium, it is a lightweight metal that can easily identify since it is usually appear as silvery white metal. In contrast to stainless steel, aluminium is made up from multiple alloying elements consisting of copper, manganese, silicon, magnesium, and zinc. With the addition of this element, it helps to improve the corrosion resistance and also provide additional strength to the metal. Aluminium is a metal that naturally protected from rust, mainly because it does not contain any iron or steel, but highly possible for corrosion to occur caused by substance that lead to metal degradation. When aluminium exposed to the air, it forms thin protective layer of oxide coating on the surface known as aluminium oxide. This coating appears extremely thin yet it successfully protects the metal underlying from additional corrosion until it is fully removed. Aluminium is utilized in a wide range of products, including household appliance, window frame, and aircraft parts. That's all for the details of the stainless steel and aluminium. Thank you.
Hi, Assalamuaikum. My name is Anuar bin Muhammad ZAWAWI. Today I want to present about the physical properties of stainless steel and aluminium. So here are a few physical properties that I want to talk about. First is density, second is melting point or melting temperature, corrosive resistance, electrical conductivity, hardness, ductility, and finally malleability. So this is the physical property. For the density of a stainless steel, which is at 7,700 kg per meter cube to 8,000 kilogram per meter cube, which is denser compared to most metal, which is make it preferable for various applications. For the aluminium, which is at 2,700 kg per meter cube, which make it lightweight. Therefore, it is flexible and desirable for many industries. For the melting point or melting temperature for stainless steel is at 1,300 degrees Celsius to 1,500 degrees Celsius. The melting point of a stainless steel also varies depending on the alloying component, which can reduce or increase the melting temperature. For the aluminium melting point, which is at approximately 660 degrees Celsius, which is a greater melting point compared to brass, iron, and copper. The melting point depends on the impurities. So next we go to the corrosive resistance for stainless steel. Stainless steel is considered highly resistant to the corrosion because the presence of chromium and other alloying elements react with oxygen to form a protective oxide layer on the surface of the metal. For the aluminium, it's also highly resistant to the corrosion because aluminium quickly develop a layer of aluminium oxide on its surface when it comes into contact with air. This layer is highly effective in preventing corrosion. For the electrical conductivity, stainless steel is considered a poor conductor because the chromium layer slows down the conductivity. The electrical conductivity is ranged from 3% to 28% of copper. For the aluminium, meanwhile, for aluminium, it is a great conductor because aluminium is an excellent conductor of electricity with conductivity of approximately 60% of the copper. For the hardness test, stainless steel is considered a high hardness because it's comparatively milder than titanium or tungsten, yet it is relatively hard in comparison to softer materials such as aluminium or copper. For the aluminium, it is a low hardness because it varies depend on the percentage of aluminium. Pure aluminium has relatively low hardness level and is soft and malleable. However, the hardness can be increased by adding alloying elements. For ductility, for stainless steel, it is highly ductile due to the composition properties that enhance its ductility, have about 50 to 60% ductility before fracture. So for the aluminium, ductility is also high ductility due to the low metal density and the metallic component which weak compared to other metals, have about 30% or 40% ductility before fracture. For the malleability of the stainless steel, the composition of chromium for stainless steel, the malleability for stainless steel is very high malleability because the composition of chromium and other properties increase its malleability. So for the aluminium malleability, the flexibility and plasticity improve the malleability of aluminium, and it can be molded into any shape without losing its hardness.
Assalamualaikum, I'm BINTI Profesor MADYA Dr. Mimi AZLINA binti Abu Bakar. My name is Nurliana binti HISHAM, and today I am going to present mechanical properties and microstructure of the material that our group have chosen for corrosive environment, which are aluminium and stainless steel. Before I go deeper into this presentation, I am going to explain the terminology of the chosen mechanical properties. Ultimate tensile strength defined as maximum stress a material can withstand while being stretched or pulled before breaking. Yield strength is the magnitude of the stress at which the transition from elastic to plastic. Next, shear strength is strength of a material or component against the type of yield or structural failure when the material or component fails in shear. Because hardness is measure of the hardness of a material. Modulus elasticity is the ratio of longitudinal stress to the longitudinal strain before the elastic limit. Last but not least, shear modulus defined as ratio of shear stress to the shear strain. Next, I am going to present mechanical properties of aluminium and stainless steel. The ultimate strength for aluminium is 89.633 MPa, while for stainless steel is 34.5 until 1000 MPa. The yield strength for aluminium is 34.7 MPa, while for stainless steel range from 25 until 2500 MPa. Next, the shear strength for aluminium is 62.05 MPa, while stainless steel is 74.5 until 597 megapascal. Next, we are going to look at Vickers hardness of these two materials. Aluminium has Vickers hardness 467 megapascal, while stainless steel is 82 until 1100. For modulus elasticity, aluminium is 69 gigapascal, while stainless steel ranges from 5.5 until 310 gigapascal. Lastly, the shear modulus of aluminium, which is 24.13 gigapascal, is lower than stainless steel, which is start from 62.1 until 86.5 gigapascal. Next, we are going to look at microstructure of aluminium and stainless steel. Generally, aluminium microstructure component is grain and grain boundaries, where grain is region where atoms have formed a crystal lattice that imparts strength to the metal, and grain boundaries is area between grains with no crystal lattice, which makes it weaker than surrounding grains. Aluminium microstructures contribute to their mechanical properties, which are high ductility and high fatigue resistance. For stainless steel, there are 4 types of stainless steel, which are austenitic, metallicity, austenitic-ferritic, and ferritic. For austenity, it consists of austenite grains, which may exhibit twinning. The microstructure also does not respond to heat treatment, and rapid cooling will produce softest condition. For metallicity, the microstructure controls bright field. It responds to heat treatment. Martensite formed through rapid cooling, and properties can be modified by using trampoline treatment. Next, for austenite-ferritic, the microstructure consists of blue ferrite and light to dark brown austenite. This type of stainless steel is ductile, and the application is widely used in food, paper, and petroleum industries. The last type of stainless steel is ferritic. The microstructure consists of ferrite grains which fine carbides are embedded. Its microstructure does not respond to hardening, and the properties is influenced by cold working. I think that is all from me. Thank you.
Assalamuaikum. My name is WANDO SIMANULLANG. I will continue this presentation about fabrication method and application. The first, stainless steel. We to discuss about how we bring fabrication method, and then how fabrication process included. So the first step in any fabrication is design and cost the stainless steel type and grade. The stainless steel component ratio is determined by the manufacturer quality. The fundamental procedure begins with melting the materials. Exercise removal of CO2 or carbon dioxide. The metal is placed in an argon or vacuum oxygen system and remove unwanted carbon. And then the steel liquid is then agitated to disperse it and remove particles from the mix. When the steel cools, it is prepared in various ways. The first step is hot rolling to prevent crystallization, and then stainless steel can also be cold rolled to produce metal plumes or billets. Then it can be heated and annealed to minimize internal tensions and change mechanical characteristics. Stainless steel is then laser cut, bent, and shaped after annealing. The next step are cutting and rolling. It's best for reducing thickness and shaping using a CNC computer numerical control mill. Lastly, stainless steel is doing choke welding. The gas used to salt is usually in thick and MIG welding. Stainless steel is then seared or coated with abrasive cut-off welds. Welds are utilized for alternative sanding and polishing as part of the steps. A series of steps will be followed after the welds have been blended and leveled. The assembly fasteners must be constructed from stainless steel, like the flat sheet and bar stock, and to help reduce the charge. The product is now ready to be assembled. B. Application of stainless steel. So, what are the application of stainless steel? For application of stainless steel is so many widely used in this world, and really helps us in many ways, such as there are automated and transportation. Maybe this is how to use the stainless steel for automotive and transportation, and then medical technology, maybe the cutting, and then building trade, maybe to use stainless steel for for this, and then aircraft construction, and then and the catering industry and tanker manufacturer. So it's very many, and then very things for stainless steel to use the earth. And then the second is aluminium. How fabrication method. So likewise with stainless steel, aluminium too, we will pay attention to the fabrication and application process fabrication. There are 4 fabrication process for aluminium. There are aluminium extrusion. Now, the aluminium extrusion in this process, powerful RAM uses heated aluminium billet die for the as the sharp final cross section form, which can take a variety of surface, including solid, hollow, and semi-hollow forms. Extrusions have a smooth surface finish and are subject to further processing to improve appearance and prevent corrosion. And then the second, aluminium casting. Casting is a excellent process for shaping aluminum into complex surface. This technique involves completely melting an aluminum alloy and injection of molten metal into a mold. The first metal builds the void completely and the solidifies to create a perfect aluminum duplicate of the internal surface of the mold. Casting may be performed with several types of molds, including the permanent molds, clay molds, and sand molds. And then forging aluminum. The aluminum rolling process involves fishing and aluminum alloy sheets or built different roll to reduce its thickness. This process is repeated until the aluminum has preserved its final shape, resulting in the fish will be considered a flat sheet of oil depending on its thickness. Fabricator and can process them further, performing operation such as bending, forming, or machining. And the last, rolling aluminum. Aluminum forging it involves saving metal by pressing, bonding, or switching its shape the desired shape. The procedure heads and the aluminum set is and use a press or hammer to deform it, but for used by forging have excellent fatigue and infrared resistance thanks to the reinforcement provided by processing techniques. And then, what's the application of the aluminum? So, the application of aluminum, this percentage, we take 6 application. There are two for architecture, and then the electronic, and then automotive, refresh, solar panel, and foil. So, aluminum is different, same to stainless steel. So it's so big and so very much to use any people for to help for us in the work. So I think this is all I can say. Thank you.
So we go to the last content, which is conclusion as what my team members present. So we can know that aluminum and stainless steel have variety of their characteristics in terms of physical properties, mechanical properties, and microstructure, and the fabrication method and the application. So as we know that these two material is really suitable in any corrosive environment. So the benefit is lifetime and durability of machinery and buildings will long last. So in the conclusion, we can conclude that these two material is really suitable in any type of corrosive environment. That's all from me and my team members. Thank you.